Imagine walking into a workshop in the late 1700s. The air's thick with the smell of charcoal and hot iron. You see a master gunsmith hunched over a workbench, filing a small piece of metal by hand. He picks up a trigger, holds it against a lock plate, and shakes his head. It does not fit. He files a bit more, checks again, and slowly, painstakingly, he coaxes the two pieces of metal to marry. This gun is a masterpiece, a unique work of art, but it is also a nightmare. If a single screw breaks on a muddy battlefield 3 years from now, that gun is useless because no other screw in the world will fit it. We recently looked at how this bespoke world began to fade as the dream of identical parts took hold. We saw how the military pushed for a system where any part could fit any machine, moving us away from the era of the lone craftsman and toward the cold, hard logic of the machine tool. It was a shift from handmade art to mechanical certainty that allowed for the birth of the factory. Now, we need to look at the frantic race to actually make this theory a reality, because thinking of an idea is one thing, but forcing iron and steel to obey a perfect standard is a different story entirely.
The problem facing the world at the turn of the century was a technical bottleneck that seemed impossible to squeeze through. To make two things exactly the same, you need a way to measure them that does not change. But in this era, measurement was a suggestion rather than a rule. An inch in one town might be different from an inch in the next. Even if you had a ruler, the human eye and the human hand are famously unreliable. If you ask 10 different men to file a piece of iron to a specific width, you will get 10 different pieces of iron. This was the hard constraint of the age. Precision was a luxury of the elite, reserved for clockmakers and astronomers. For everyone else, the world was slightly crooked and mostly approximate.
The race to change this was driven by a desperate need for scale. Governments were tired of waiting months for a shipment of muskets that might not even work together. They wanted thousands of items, and they wanted them now. This created a massive pressure cooker for innovation. The goal was to take the skill out of the hand of the craftsman and build that skill directly into the machine itself. This meant inventing a new category of objects called machine tools. Think of these as the ancestors of everything in your house today. These were machines designed to make other machines.
The breakthrough moment came when innovators stopped trying to make parts perfectly and started trying to make them identical. There's a subtle but massive difference there. To make something identical, you need a guide. Imagine trying to draw a perfect circle. It is nearly impossible to do it freehand. But if you use a compass or trace the rim of a glass, you can do it every single time. The pioneers of this era began creating jigs and fixtures, which were essentially physical templates for metal. They would lock a piece of raw iron into a frame that only allowed a cutting tool to move in one specific path. Suddenly, you didn't need a master smith with 40 years of experience. You just needed a person who could turn a crank and follow the guide.
This was the birth of mechanical memory. The machine remembered the shape, so the human did not have to. But even with these guides, there was a deeper problem. Metal is a living thing in a way. It expands when the sun hits the workshop roof, and it contracts in the winter chill. The machines themselves would wear down. The very tools used to create precision would slowly lose their edge, drifting away from the standard. This led to the development of the master model system. A single, perfect version of a part would be kept in a velvet-lined box, never to be used, only to be copied. Every tool in the factory was checked against this silent, perfect reference. This was the beginning of the quest for absolute truth in manufacturing.
As these systems began to work, the world started to change at a dizzying speed. It started with weapons, but it quickly leaked out into the civilian world. Consider the humble clock. Before this race for precision, a clock was a massive investment, something a family might pass down for generations. But once you could stamp out gears and plates that were all identical, clocks became cheap. They became tools for the common person. The same thing happened with locks, with sewing machines, and eventually with farm equipment. The economics were simple but transformative. It cost a lot of money to set up the machines and the gauges, but once they were running, the cost of each individual item plummeted. This was the moment the modern consumer world was born.
The ripple effects of this race were felt everywhere. The winners were the nations and companies that could master this high-tech language of measurement. This era saw the rise of the specialized factory worker. In the old days, a worker might see a project through from start to finish. Now they stood at a machine and performed one precise task over and over. It was efficient, yes, but it changed the nature of human labor. The skill was no longer in the muscles or the eyes of the worker. It was locked in the gears of the machine they operated. This created a new kind of wealth and a new kind of tension in society. But there was a hidden benefit to this cold, mechanical system that we still rely on today. This race for precision created the concept of the global supply chain. Because parts were now standardized, you did not need to build the whole machine under one roof. You could make the wheels in one shop, the frame in another, and the bolts in a third. As long as everyone was using the same master gauges, the pieces would fit together perfectly when they met. This allowed for an explosion of complexity. We could suddenly build things that were far too complicated for a single person to ever understand or create on their own. By the mid-19th century, this system had become the standard. The race was over, and the world of the unique, handmade object was fading into the background. We had entered the era of the duplicate. Everything from the buttons on a coat to the rails on a train track was now part of this vast, interlocking web of precision. This transition was the essential bridge between the old world of wood and stone and the new world of steel and speed. Without the ability to make things exactly the same, the Industrial Revolution would have stalled. It would have been a collection of interesting inventions that could never be shared with the masses. Today, we live in the aftermath of this race. When you buy a replacement battery for your phone or a new tire for your car, you are benefiting from the struggle of those early engineers who fought to make an inch mean the same thing in every workshop. We take it for granted that things will fit, but that fit was earned through decades of trial and error. It is an invisible framework that holds our entire material world together. Every time you turn a key in a lock or plug a cable into a socket, you are seeing the final result of a time when the world decided that being identical was the most important thing a product could be. This mastery of metal and measurement provided the blueprint for every complex machine that followed. By learning to manufacture identical parts with absolute precision, we paved the way for more powerful and intricate systems. Next, we will move forward in the timeline to see how these fundamentals allowed for the birth of the internal combustion engine. Join us as we explore how the quest for power moved from the steam boiler to the cylinder and changed the stakes of human travel forever. If you are enjoying this journey through the history of technology,